Hmm. నేను చెప్తాను నీ కథ ఇప్పుడు కాదు. त्या आरतीला पाहिजे बाळाचा किती तांदूळ पाहिजे కొత్తిమీర ఎలా కుమ్మింది ఇస్తుందా నేను యారో ఒకటి తెలియాలి నా పప్ప ಮತ್ತೆ ಎರಡು ಮುಷೆ ಕಳ್ತಿದ್ರು ಮೂರು ಡ್ಯಾನ್ಸ್ ಮಾಡಕ್ ನೋಡು ಯಾವ ಹೀರೋಯಿನ್ ಯಾವ
Yeah, it's in hand 1.8 lakh Pro. Okay. Currently, I haven't. We'll get back to you after probably 1.5. Is that okay? Great. Yeah. थांबली होय.
This brother. Okay.
Kyle.
काही का छटना एग्जाम लागले को हाँ एग्जाम पेंसिल दे
Hello all. Welcome to last day session of VLSI Masterclass. In the past 4 days session, we have discussed about VLSI, its basics along or gate coding. Today we are going to talk about protocols. Prithvi, please continue.
Yeah. Thanks, Shivani. Hello all. Good evening, and I hope everyone is doing well. And welcome. I would like to welcome you all onto the day 5, that is the last session of masterclass on VLSI. In the background, I am getting noise from who is this? Hello. Hello. Am I audible to you all?
Yes, Prithvi, you can.
Yeah. So just before, am I audible?
Yes, Prithvi, yes.
Yeah, thanks. Thanks for the confirmation. Okay, so welcome you all on to the last session of our masterclass on VLSI. Okay, so hope the screen is visible to you all, right? Is the screen visible?
Yes, Prithvi.
Yeah, thanks. Yeah. Okay, sir. So see, let us quickly in our yesterday's discussion, we have seen like how to write a code. Oh, actually, I'm getting echo from someone. I'm not sure who it was. Okay. Yeah. Yesterday we have seen a 2x1 mux. Right. Yesterday we have seen code for 2x1 mux in what level? Gate level modeling style, right? Now see, and how many levels of abstractions are there in Verilog? Can you guys respond through chat box? How many levels of abstractions? What are they? What are they? Among them, which one is the highest level of abstraction? Yeah, behavioral is the highest level of abstraction, followed by data flow, then gate level or structural modeling, then switch level, right? Among all these things, switch level is the lowest level of modeling style, right? Among all these things, switch level modeling style is the lowest level of modeling style, and behavioral is the highest level of modeling style. That is what we have seen, and we have also seen like why behavioral is the highest level of abstraction, why switch level is the lowest level of abstraction. So we have seen the codes with respect to data flow style of modeling and gate level. So today let us quickly see the code for a behavioral modeling style. Okay, let us quickly see the code for a behavioral modeling style. So here I have written a code for a 4x1 mux. Okay, I hope everyone knows the functionality of a 4x1 mux, but yet still let me once quickly go through the functionality of a 4x1 mux. See, this is a 4x1 mux and it has something like this. Assume that A, B, C, D are the inputs, and here it will have two inputs, right? Like 1 down to 0, S, and then one output. So here there are two things, S of 1 and S of 0. So they can have four different values, 0, 0, 0, 1, 1, 0, 1, 1. If it is 0, 0, what is the output? Output will be A. If it is 0, 1, B. If it is 1, 0, it is C. If it is 1, 1, it is D. It is as simple as that. So I have written the code for the same thing here. That is what you can see here. Initially, what did I do? I have taken all the required necessary inputs and output ports, and then I have given direction to them, like input A, B, C, D, input 1 down to 0, SEL, then output out. Here, as it is behavioral modeling style, it is required that all the output variables should be declared as rich. Okay. We have to declare all our output variables as rich. It is mandatory. And then if you see here, how many selection lines are required for a 4x1 mux? I need two selection lines, right? So that is the reason I have taken here two selection lines. Here, if I write like this SCL, it means that it is only one signal. If I write like this 1 down to 0 SCL, it means that it has two signals into it. One that is SCL of 1 and SCL of 0. Okay, so that is how here I have taken my two selection lines, SCL of 1 down to 0. Now see here. Here, if at all you are trying to write the code in behavioral style of modeling, then it is must that you have to use procedural block. Here, always is a procedural block. Always is a procedural block. Okay, always at the rate star. What does this star? Star means that whenever Hamsita, whosoever, Hamsita, please share. I request all the participants to mute yourself. Okay. Or I request Shivani to make sure that every participant is muted except me. make me host.
Yeah, sure, Prithvi, sure.
Yeah. Sorry for the inconvenience. Meanwhile, I request everyone, please mute yourself and let's not cause any trouble to the class which is ongoing here. Thanks for your understanding. Okay. So here I have taken the inputs and have taken required selection lines, and here I have taken always at star, and between begin and end I have written something. What does this star means is, like, whenever either A, B, C, D are my SCL, any one of these changes, then I want my code to execute. It means that I want my always block to get triggered. Okay. At first glance, it could be slightly difficult for you guys because you are seeing it for the first time and it is only the day 3 of what you are seeing as part of the code is considered. So don't worry, but you just assume like this is the structure of a Verilog code and you just go with the flow for now. Later you can understand it. Okay. So here what am I doing? If my selection line is 0, 0, if SCL equal to 2 tick B 0, 0. See here, if my selection line is B 0, 0, what should be my output here? My output should be A, right? So that is the reason. What did I do? I made out equal to A. Okay. Here begin and are optional actually. Okay. For time being, let me remove these begin and end so that you will not confuse. Okay. Fine. So see here. Yeah. If selection is 0, 0, I want my output to be A. If selection is 0, 1, else if my selection is 0, 1. So see here, if my selection line is 0, 1, see here, if my selection is 0, 1, then what should be my output? My output should be B. Else if my selection is 1, 0, if my selection line is 1, 0. So see here, if the selection line is 1, 0, what should be the output? Output should be C. So that is the reason I have taken output equal to C. Else if my selection line is 1, 1, see here, then what should be the output? Output should be D. Okay, output should be D. Actually, this last line is not required. Okay, even if you comment it, there is nothing wrong. That is a default statement. Now, so let me try to execute this. See, the test bench is quite similar to what we have discussed yesterday, but yesterday we have discussed test bench for a 2x1 mux. Okay, and today what I have here is a test bench for a 4x1 mux. That's it. No any difference as per the test bench is considered. I have just given some values for A, B, C, D and the SCL. Okay, as my SCL is 2-bit, 1 down to 0. So I have given 2-bit value to this. SCL equal to 2 tick B 0, 0, 0, 1, 1, 0, 1, 1. Like, I have given some different values for selection and ABCD. It is as simple as that. Okay, so let me repeat this design code again. Here our main focus is on the design, but not on the test bench. So if my selection is 0, 0, I want my output to be A. Okay, 0, 0, 0, 1, 1, 0, 1, 1. If selection line is 0, 0, okay, and this is my multiplexer, okay, which has A, B, C, D as its inputs, and this is my selection line. Okay, this is my output. If selection is 0, 0, what should be the output? A should be the output. So output should be equal to A. If selection is 0, 1, then what should be the output? Output should be B. If selection is 1, 0, then what should be the output? Output should be C. If selection is 1, 1, what should be the output? Output should be D. That's what I have written here. If selection is 1, 0, what should be the output here for 1, 0? C. So out equal to C. Else if selection is 1, 1, then what should be the output? Output should be D. Actually, even though if you don't write this line number 16 and 17, nothing wrong. Okay. So for time being, let me remove these two lines. If not, you will confuse. Okay, let me run this code quickly. Now I am running the code and here you can see the waveform. Okay, let us try to analyze this waveform. let me place my cursor initially, okay, see here, SCL is 1 down to 0. This is the MSB, okay, here this is the MSB and this is the LSB, okay. So let me place my cursor, okay, at this 0 in 0 nanoseconds. Now my cursor is at 0 nanoseconds, and at that time, what are the values of selection line? Selection are 0 0, okay, 0 0 0 1 1 0 1 1. If value of selection is 0 1, what should I see at the output port? At the output port, what should I see? I should see the value of A, right? What is there in A? What is there in A? 1 is there. Is that 1 captured to the output? Am I able to see that 1 here? Yes, I am. See, what is there in A? 1 is there. Is that 1 captured to my output or not? Yeah, that is what I can see here. From here to here, output is 1. As clear as that. Now, let us go to the second observation point. Okay, let me place my cursor here at 10 nanoseconds. Here you could see, now I have placed my cursor at 10 nanoseconds. At 10 nanoseconds, what is the value of selection now? You see, value of selection is how much? 0, 1. Okay, value of selection is how much now? 0 1. 0 1 is nothing but what? This is a vector representation. Okay, so 0 1 is nothing but 1, and if you want to see its individual vectors, you just need to click on that plus symbol, which is 1 0 0 1. So if it is 0 1, what should come to the output? B. What is there in B? What is there in B? In B I have value of 0. Is that 0 captured to the output? Yes. Is my B and out are same or not? Yes. See, that's what we can see here. My output is transiting from 1 to 0 here. Okay. Same output is captured here. Same. Now, let us go to the next observation point. Okay. Let me place my cursor here. If you see here, what is the value of selection you are seeing here? What is the value of selection you are seeing? See here, 1 0. 1 0. If it is 1 0, what should be the output? Output should be C. What is the value that is there in C? See here, what is the value that is there in C? In C I have 1. And is the same value captured to the output or not? Yes, it is captured. My output is 1. That is what I can see here. It is transiting from 0 to 1 here. Okay, my output is capturing the value of C. Okay, now let us go to the final observation point. Now, what is the value of output here? Selection line here. Value of selection line is 1 1. Value of selection, oh sorry, it is 1 1, right? If it is 1 1, what should be the output? Output should be D. Means whatever the value that is there in D, the same value should be captured to the output. Is that captured or not? Yes, it is captured. In D I have a 0, and same 0 is captured to my output also. That's it. Okay, as my value of selection is 1 1 throughout, so even my value of output is also equal to D throughout. As you can see here, my D is changing, so my output also changed here, because my selection line is still 1 1. Even here it is 1 1. So that is the reason my output is equals to D. Okay, this is how you have to analyze a 4x1 marks. Clear? Okay, so in past few days, we have tried to learn on, like, what is Verilog, what is VLSI, and what are the different roles offered in VLSI industry, and how many profiles, like, if at all you want to enter into the industry, what is the roadmap or pathway to the industry. And we have seen in Verilog, we have seen few things like few coding, like, data flow style of coding, gate level modeling style, and behavioral modeling style we have seen. Okay, now there is something which is advanced from Verilog. Okay, what we have seen so far is Verilog. There is something advanced from Verilog, that is SystemVerilog. Okay, so enhanced or advanced version of Verilog is called SystemVerilog. Okay, SystemVerilog has a very good features compared with Verilog. Like, in SystemVerilog, dynamic concepts comes into the picture. That is the concept of OOPS, object oriented programming, comes into the picture. This is where, class based test bench will be coming into the picture. The problem with Verilog language is it has lesser data types, and SystemVerilog will be having more number of data types. The data types are more in SystemVerilog. Not just that, SystemVerilog, it will be having few features like randomization. I will tell you what is randomization. Okay, it has some features like randomization and coverage analysis. All these things are not possible in case of what Verilog, and also assertion based verification is possible here in SystemVerilog. So SystemVerilog has some enhanced features, like if at the moment we can also write constraints in SystemVerilog. Okay, so what is randomization? For example, see, if my selection is of 2-bit, that is SCL of 1 and SCL of 0. For this, how many possible input combinations are there? 0 0 0 1 1 0 1 1 means totally 4 possible combinations. As it is a 2-bit one, it is 2 power 2 equal to 4 different combinations I got, so that I can write them manually. What if I am writing a code for a let us assume like 128 cross 1 mux. For 128 cross 1 mux, I need 7 selection lines, right? I need 7 selection lines. It means that I have to write 2 power 7 equal to 128 different input combinations I will be getting. See, if it is 2-bit vector, I am getting 4 different values. Similarly, if it is 7-bit vector, I will be getting 128 different values. For example, my requirement is that I want to design a 2048 cross 1 mux. So will you be generating these many lines of code, like 2 power 11 lines of 11 different input stimuli will you be generating? If it is only 2-bit, you are able to write 0 0 0 1 1 0 1 1, that is okay. But will you be able to write for 11-bit vector? Quite difficult, right? So that is where this randomization will help us. Like you can randomize all your inputs, and you can write few constraints, and you can even say like how much part of your code is covered by using something known as coverage analysis, and you can even verify whether something you have written is correct or not by using assertions. I know all these things looks quite weird or unfamiliar to you, but don't worry, you just started to know what is Verilog. So if I tell you all these things, so you will run out of this class. So I don't want to discuss anything much onto this. But at this point of time, it is good to know that there is something else that is existing known as SystemVerilog, which has some advanced features in comparison with Verilog. Okay, and this is most widely used. Okay. Okay. Just a moment, guys. Okay. So now let us try to know like what is a protocol. Okay, if you remember like our pathway to VLS industry, just give me a moment here. Can you guys please don't mind me? Just give me 1 minute. Yeah, so in our yesterday's discussion, we have in our day 1 discussion, we have seen like what is the roadmap to get into the VLS industry. Yeah, in that we have seen one slide. Okay, it is something like this. Okay, let me share the screen back. Yeah, it is something like this. Yeah, see here. It is something like this. Where we have seen like you should have strong knowledge in digital. You should have some knowledge in Verilog, SystemVerilog or UVM. You should have some debugging skills. Then you should have some knowledge on standard tools, any one of the EDA tools. And then what else is required? You should know some knowledge on protocols. Okay, so we have seen so far we have discussed these things. Now let us see, or let us try to know on what is a protocol. Okay, and what is its significance of protocol, how many types of protocols are there, all those things we will try to focus now. Okay, so what is a protocol? Generally, in general sense, like protocol means what? A set of rules. Okay, general, what is the general meaning of protocol? Protocol is nothing but some set of rules, as simple as that. So why should you need rules? Here, with respect to our semiconductor industry, we need set of rules to transmit the data. Okay, if at all you want to do data transmission, you cannot do it as per your wish. Okay, there exist some rules for the data transmission. Okay, for example, I have a chip boundary. In this, there are many modules are there. Okay, many subsystems are there, many IPs are there. For example, I want to transfer the data from this end to this end. So it is not that you will outrightly connect one wire and data will be transferred automatically. No, it does not happen like that. So there should be some medium that is existing between this module 1 and module 2 within the chip. Okay, so and for doing data transmission, we should have some medium, and that medium is bounded with some protocols. Okay, so protocol is nothing but what? Set of rules. Why are the set of rules? These set of rules are required for transmitting the data from one module to the other module, or one block to the other block. The moment I talk about protocols, there are two different types of protocols for us. Okay, two different protocols exist for us. One is the on-chip protocol. Okay, and other one is the peripheral protocol. One is what? On-chip protocol. Other one is peripheral protocol. On-chip protocol means this is between the components within the chip. Okay, this is between the components that is inside the chip. Whereas if it is peripheral protocol means here it is outside the chip boundary. It is with outside the chip boundary. For example, this is my chip. Okay, in this there are many components, component 1, 2, 3, 4, 5, 6, 7. So if these components want to communicate with each other, then what we have to use is on-chip protocol. For example, I want this chip to be interacting with some other user interface, or I want this to be interacting with some other chip or some other FPGA, something. So then what comes into the picture is a peripheral protocol. Here, if it is within the chip, it is on-chip protocol. The name itself is telling on-chip protocol. If it is outside the world, then it is peripheral protocol. Okay, so what are the examples of on-chip protocol and peripheral protocol? The examples for on-chip protocols include all your AMBA protocols, like AXI, okay, APB, AHB, and PCI. All these things are your on-chip protocols. If it is peripheral protocol, you can guess these peripheral protocols. Like if you take your laptop, what are the peripherals of your laptop? USB. USB is a peripheral, right? So USB is a peripheral protocol, and I2C is a peripheral protocol. UART is a peripheral protocol. So there are different protocols, peripheral and on-chip protocols. Okay, here if it is a peripheral on-chip protocol, in on-chip protocol the data communication happens between components in form of transactions. Okay, here it happens in form of what? It happens in form of transactions. But if it is peripheral protocol, here the data transfer happens in form of packets. Okay, it happens in form of packets, or I would say it happens in form of frames. Wherever you see a packet is sent from component 1 to component 2, by the term what you should understand, it means that this is a peripheral protocol. Wherever you see here the data is sent in form of transactions, then it means that it is a on-chip protocol. Okay, here there are many things. If you go inside and deep dug into what is a protocol and all, there are many phases into them. Let's not touch them. But if you take any protocol, all these protocols will be having like for example, you want to develop a chip, or you were given a module ownership. Assume that your module is having these two components in it. Then you have to make sure that these two components are talking to each other without any interference. Then which protocol will you choose? Here, which protocol shall we choose? On-chip protocol or peripheral protocol? As it is within the chip, we have to choose on-chip protocol. And I have many on-chip protocols like AXI, APB, AHB, PCI. So among these, which one should I choose? It depends upon the requirement, like what you need exactly, like what is the performance you need. By performance, I mean like how much is the bandwidth you need. By bandwidth, what do I mean? Like, what is the maximum amount of data you want to transfer? Depending upon that, you can choose any one of them. Either it is AXI, APB, or AHB, something like that. And then after that, what is the power consumption? Like, what are your demands with respect to power consumption? Should you need optimum efficient power consumption or normal power consumption? Or like you want how many number of features you want to be supported? Okay, the moment you choose more features, then the more complex protocol you have to choose. Among all the protocols I have discussed here, okay, AXI, APB, AHB, PCI. APB is a basic protocol, okay, which has limited features and whose performance is also comparatively less. Okay, for example, let me give you a basic idea. Okay, for example, let me give you one small comparison between APB and AXI. Oh, wait. Okay, let me give you some small comparison between APB and probably AHB. Okay, assume that I want to send something like 50 bytes of data I want to send. Okay, I want to send 50 bytes of data. If it is APB, okay, for every transaction in APB, I need 2 clock cycles. Okay, I need 2 clock cycles. For example, see here, this is my clock. See, don't try to think like I'm teaching something out of the box. Here I'm trying to concise what I know in a much optimum or much efficient way to you. Okay, so don't think like I'm teaching something rocket science or something. It is quite basic actually. I'm teaching it to you in a very optimized and in a such a way that you will be able to understand it very easily. Okay, so assume that this is the clock, and if at all I want to send 50 bytes of data, assume that in each transaction I can send 1 byte of data. Assume that in each transaction I can send 1 byte of data. Means totally how many transactions do I need? How many number of transactions I need? Can anyone comment? As I send 1 byte in each transaction and my total amount of data to be transferred is 50 bytes. So I need 50 transactions. If at all I want to send 50 transactions, the question is how many clock cycles does APB require? APB needs how many clock cycles? See, I told you each transaction requires 2 clock cycles. Here I have to do 50 transactions. 50 transactions means 50 into 2. Totally how many clock cycles I need? I need 100 clock cycles. And here the data happens like this. Okay, here initially I will be sending address and then I will be sending the data A1, D1, and then I will be sending A2, address 2 again, then I will be sending the data 2, then I will be sending address 3, then I will be sending the data 3. So what is happening here? On one clock cycle I am sending the address, in the next clock cycle I am sending data, again address and data, again address and data. Means if you see here, in one clock cycle I am sending the address, and in the second clock cycle I am sending the data. So each transaction is taking how many clock cycles here? 2 clock cycles. In one clock cycle I am sending the address, and in second clock cycle I am sending the data. But this is what? This is with respect to APB. What if I use AHB? If I use AHB, AHB has some enhanced features in comparison with APB, and it is like this. Okay, assume that this is my clock. Okay, this is my clock. Here I will be sending the address. Okay, address here, and then even in the next clock cycle also I will be, so here it is happens something like this: A1, A2, A3, it so on goes like this. Here the thing that happens is, in the next clock cycle onwards you will also start transmitting data. Okay, so here with respect to corresponding data of A1 is sent here, and its corresponding data of A2 is sent here, and next corresponding data of A3 sent here. So what is happening here? if you see here, initially data is sent, then address is sent. Sorry, initially address is sent, then data. Address, then data. But here, initially address is sent. From the next clock cycle onwards, both of them are going. Address and data. Address and data. Address and data. Okay. Address and data. Both of them are going. Means AHB is having something like a pipelining process. Okay. It has some advanced feature like pipelining. So for this, can you guys tell me like how many clock cycles does it require to transfer the data? If it has 50 transactions, and in each transaction, if it has 50 bytes of data to be transferred, and in each transaction I can send 2 bytes of data. So can you tell me like just a minute, it is 1 byte, right? I have 50 bytes of data, and in each transaction I can send 1 byte of data. So totally how many transactions I need? I need 50 transactions. The question is how many clock cycles? How many clock cycles AHB requires? Can anyone answer here? Yeah, 51. Exactly, correct. It is 51. Okay, here we need 51 clock cycles. See, my APB is requiring 100 clock cycles because in for transmitting the data, it requires 2 clock cycles. Okay, one is for address, other one is for data. But here, only in the first clock cycle, address is sent. From the second clock cycle onwards, both address and data are sent in parallel, right? It means that it is some enhanced feature. That is the reason here how many clock cycles I need? Only 51 clock cycles. It means that it is my AHB is faster in comparison with APB, and here I am saving power also. But what is the thing here? See here, you are sending address and data alternatively, but here you are sending address and data together in AHB. It means that AHB is somewhat complex. So the complexity increases. It means that as you want more features, then what happens? The complexity of protocol increases. Okay, the complexity of protocol will increase like anything. Okay. Hope it made some sense to you all. Yeah. Okay. So okay. So you know, ARM is a company, right, which produces all your RISC-based processors. You know, there are two kinds of architectures, right? CISC and RISC. ARM produces all the RISC-based processors. So ARM has 3 series of processors. One is the A series, other one is the R series, and other one is the M series. So it has basically what I want to tell you is where are we using these protocols? I have told you like these are protocols. Where am I using these protocols? For example, AXI is there. You know, in AXI there is something known as AXI live. Okay, this is on AXI stream, AXI live, XM. These are in fact these are the protocols that are used to broadcast your data. You are watching the live stream, no, like you know, live cricket, live hockey, live football, or whatsoever. It is transmitted using the AXI protocol only. Okay, that is done by using AXI only. So let us see like where can these protocols are used. As ARM has 3 series of protocols: A series, R series, and M series. In all these processors, any one of the protocol is being used. For example, if I say A series stands for application. Okay, okay, application. In this, you know, all your mobile phones or all your laptops. So all these things will be having these A series processors. Okay, are all your mobile phones, and you know, your mobile phone is equipped with SoC. It means that all your mobile phones, SoCs, or laptops, or whatsoever you see, all of them are using this application based thing. And in this, what is the protocol that is used is in A series, probably it is AXI protocol. Okay, mostly it is AXI protocol. And if it is R series protocol, R stands for real time. Okay, where you need the data on real time, where you need the real time data. Like you know, it is used in all your safety critical processes, like deployment of your airbag kind of things. So I mean, so it is used in all these automotive things. It is mostly used in automotive things. And the protocol that is used in R series processors is AHB protocol. And M series stands for medium performance. Okay, M series stands for medium performance. Here, even here, you will be using like AHB protocol. In fact, the M series processors are being used in your washing machines. Wherever you see washing machine, and if it is obviously it is using ARM processor, and it is having AHB protocol into it. Not just washing machine, all your microwave ovens. Okay, these things will be having these M series processors into them. Okay, so like this is the practical significance, or this is the practical live scenario where all these protocols can be used into your real-time scenarios. Okay, you cannot imagine a life without protocol if you are a DV guy, or even though you are a designer or a DV guy, the protocol is must for you. Okay, you should have the knowledge of protocol. And okay, so with respect to this, on our roadmap to the VLSI industry, okay, what we have seen, we have discussed like a few of digital concepts like full adder, and then we have seen few codes with respect to Verilog in different levels of abstractions, and we have seen like how to access EDA tools. And then we came to know like what is a protocol, what is the significance of a protocol, how a protocol should be used or where should be used, and what are the real life scenarios where it is already being used. All such things we have seen, right? So now I just want to give you a little more knowledge, or I just want you, I just want to dig deeper a little more into it. Okay, don't scold me if you don't understand what I'm going to discuss now. Okay, but it is a good to know knowledge for you, and it is somewhat high level as per me. It's okay, but you try to understand it. Okay, so whatever the protocol that we have seen so far, okay, that is known as an IP. Okay, IP stands for intellectual property, and Cadence is a company which is very well known for producing IPs. Uh, so if at all you enter into the industry, you will be offered like you will be initially you will be asked uh, you will be given a small block to work on to. Okay, you will be given some small block to work on. If you are done with small block, means initially in your period of 0 to 2 years, they will give some small module or small block they will ask you to develop. If at all you have developed this small block successfully, then you will be promoted to something known as IP level verification or IP level thing. So what does this IP level thing will be having is it will be having lot of these small blocks into them. So you are responsible for taking care of all these blocks on your own. You will be given an ownership. Okay, initially it is like small block. Once you're done with the block, then something like IP level will be coming into the picture. Once you're done with IP level, then something like a subsystem comes into the picture. Once you're done with subsystem, then something like a SOC comes into the picture. SOC nothing but system on chip. So this is IP level. Then so you will be working on IP level probably in 2 to 4 years of time. Once you're done with IP level, you gained little maturity over IP level, then you will be pushed on to something known as a subsystem level verification or subsystem level engineering. In the subsystem level, what is there is it has lot of IPs into it, like IP1, IP2, IP3, okay, IP4, like this. In this subsystem, it will be having lot of things into them, and in between these different IPs there will be bridges in order to communicate between this. Okay, so between your 4 to 6 years of career you will be working on subsystem, or even you will get a chance to work on SOC also. So what is SOC? In SOC, what you will be doing is, see, it will be having lot of subsystem into it, like subsystem 1, subsystem 2, subsystem 3, subsystem 4. So where you have to take care of all the subsystems. So as you move forward from block level to IP level to subsystem level to SOC level, your experience increases and the complexity of the work will also increase like anything. More the knowledge you get, greater will be the opportunities for you. I mean, greater will be the scope for you to develop. Okay, so this is how typically the flow in industry goes. A small Block level is easy, and SOC level is quite difficult because you have to take care of lot of peripherals into them. Like, subsystem 1 is nothing but they will be naming it something like this: perif 0, perif 1, perif 2, perif 3. You have to take care of all these peripherals on your own. If at all you are given a ownership of SOC, if it is subsystem, you have to monitor all your IPs. If it is at IP level, you have to take care of the whole bench with respect to that IP level. So this is how it varies. Okay. Fine. So let me go through this thing very quickly again. Like, uh, basically I'm done with the discussion and I'm done with what I want to tell you for today. So I just want to recall this page again. Like, how can you be industry ready? What you have to do in order to be industry ready? As I have told you, you should be a trained professional, and we are here to help you with respect to this. Okay. And so what are the things that you should have if at all you want to be industry ready? First thing is, you should be having good knowledge in your digital design. For example, if I ask you a question like, if at all I have a input frequency of 50 megahertz and I gave it to some module or some block and I want to get an output frequency of 25 megahertz, what is the circuitry you are going to use here? Simple question. What is the answer? I have given 50 megahertz as the input and what I want is 25 megahertz as the output. So what will you use in this block? Yes? Anyone? Can you guys give me the answer? Yeah, frequency divider. That is fine. Frequency divider is fine. But that is not a precise answer. Means what is the thing that is having a that is there in frequency divider? Demodulator. Okay. See, what is the mod number of Johnson counter? What is the mod number of Johnson counter? Or what is the mod number of an asynchronous counter? For Johnson counter, I guess it is n, right? Similarly, what do you mean by mod number? Mod number is nothing but different states a given counter can count through. So if I give an input frequency of 10 to a Johnson counter, then what is the output frequency I will be getting? It is 10 by n, right? So it is divided by the mod number. So here what should I have? I have some counter, like, which has mod number as how much? Mod number as 2. Okay. Something like that. Means you should be having this kind of practical thing to your digital electronics. And then you should be having good knowledge over these programming languages like HDL, which is Verilog, and then SystemVerilog, which is enhanced version of Verilog. And then there exists one methodology known as UVM, Universal Verification Methodology, and you should be having very good knowledge over it. Once you are done with this, then you should have some debugging skills or good analytical ability should be there. After that, then you should have some good hands-on experience into your industrial tools or any or EDA tools like, Aquesta Sim, Xilinx Vivado or whatsoever. So you should have good hands-on to our industry level experience tools. Once you are done with this, then you should have some good knowledge on protocols. That is what we have discussed, like what is a protocol, significance of protocol, where it can be used, what are its real-time scenarios on which we are using them. Like, you should be having any good knowledge over PCIe, USB, Ethernet, AMBA, AXI, APB, any one protocol you should be having some knowledge. Once you are done with that, then it is optional. Okay, for a beginner, it is optional to have knowledge on any one of the scripting language like, Tcl, Perl, or Python. In semiconductor industry, what preferred is Perl is preferred mostly. Okay, Perl or Tcl is preferred mostly, but even if you know Python, it's nothing wrong. When I was working as an intern at ST Microelectronics, as an intern, the first task given to me was to learn Python and write one script. Okay, so scripting is also, even though if you don't know the scripting language, they will make you learn it at the industry. Okay, yeah, that's all. Yeah, that's all from my side for today. In order to be industry ready, we at HAWE will help you to be industry ready, and I myself can give you the training. Okay, So if at all you are interested, please come back to us, and I will be waiting for you. Okay, so if you have any other doubts, please let me know, yeah.
Yeah, thank you, Prithvi.
Yeah.
Yeah, guys. We have our first ever new batch of VLSI on 20th Jan 2025. If you are interested, you can register over the link in the chat box our team is posting. And further more details, you can free to contact our team members. They will approach you and they will let you know all the doubts. And during the session, do you have any questions? Please, you can feel free to chat in the chat box. Okay.
Yeah, even I will be teaching digital electronics also. Yeah, okay, let me tell you, as a part of the course curriculum, I will be teaching you digital electronics, Verilog, SystemVerilog, UVM, and depending upon your interest, it will be. And on after once we are done with UVM, I will be teaching you one real-time project. Okay, real-time industry-based project will be given. You are asked to. In fact, you are the one who has to write code for everything, all the components or whatsoever. So that is how the structure is. Okay, so is there any placements of VLSI company? Yes, yeah, we are working on that, and we are already in type with few companies. So probably this thing, we are taking forward with respect to this in our near future. Yeah.
Prithvi, there is a question from Arabindo. In digital circuits, we have tip-flop, which can be used for frequency
Yeah,
division
you
by
can
two.
use any flip-flop. See, flip-flop, you can use counter here, okay? Whatever the counter you want to use, it is up to you. How you want to design the counter, it is up to you. My area of interest is what you have to use there. Counter, that's it. Okay. Is Xilinx Vivoda enough for Verilog? Yes, yeah, it is.
There is a question from Arabindo again, Prithvi. Sir, is it possible to use a T-flip-flop for frequency division you asked in last?
Yeah, that's what we can do that. Okay. Yes, yeah, this is common industry ready for. Okay. So as I'm a DV guy, so DV means design verification, especially the front end. So my major focus in this discussion is front end, Srihari. So this is your approach for being a front end engineer. Okay, front end. If it is back end, the design set, the skill set will be different. Like you should be having knowledge on your analog electronics, very good knowledge, very good command over your analog electronics, especially all those CMOS concepts. Okay.
Prithvi, there is a question from Harshit, like which tools we use for UVM, sir?
Yeah, your Questa sim you can use whatever the tools I have told there you can use those tools. One tool that we generally use is Questa sim.
Sir, do you provide placement for the course? Yes, Suprita, we will provide the placements also for this course. You can join HIEE. We will also provide the placements also. And can we get work from home jobs from Pallavi?
See, yeah, being a fresher, you should not do, even if someone is telling you to do work from home, you should not do because you won't learn anything. Believe me. Okay. Even though some people is offering you work from home, I request you go to office and work. And it is possible, but be for a fresher, no one will allow work from home. I mean, to a greater extent, it is not possible. At least they will ask you to come to office at least 3 days a week here. Okay,
There is
how
a
can
question
we?
from, sorry.
It's okay. How can we optimize the logic with respect to power? See here, all these things, the synthesis guy will take care of this. Okay. Basically, if you want to optimize it, you should know, no, like how much is the power first of all it is consuming. Depending upon that, as with respect to code, you are not doing anything. Being a designer, what you will be bothering about is the functionality correct or not? That is what you are bothered about. Okay, there is something known as PAV, power aware verification. So he is that guy who is going to take care of those things. Okay. Actually, there are a lot of things in order to take care of that power. Okay. Yeah, any other questions here?
Yes, Prithvi, there is a question from Yashita, sir is definitely a TVS company related to EC course. Do joining that company help EC students to gain experience on embedded systems?
I'm sorry, yaar. I'm sorry to tell you, but I don't know about this company, yaar. I'll go back and look into this. I'm sorry, I cannot help you with this.
Sir, please tell me some projects ideas. It helps us me to submit in fourth year project.
Project ideas with respect to VLSI, the best thing you could do, is design one IP and keep it as your project. If you at all you are able to design one IP, no, you will even be able to publish a paper on it. Okay, it is not an ordinary thing. If at all you are able to design an IP, no, it is like all industries, all the product based companies will come you and offer you like anything and they will pick you. Okay, and we are here to help you that. We help you with respect to that. I am here to help you with respect to that. Okay.
Prithvi, there is a question from Nitin. What is the difference between static and dynamic CMOS logic?
uh, CMOS logic. See, yaar,
Yes.
I'm not much into the physical design things, so probably I'm not the appropriate person. But yeah, to answer that, because even whatever we have discussed so far, my major area of focus is on DV, that is the design verification or the front end thing. Okay.
Yeah, Prithvi, one more question from Aravinda. For PD, what should be target for final year project?
I am not sure about this year. Probably because I am already in touch with some PD guys, and I am working on to get PD also into this. Okay, probably PD. I am planning to bring PD into the picture by mid of February. So by that time we will be, we are planning to held one more session that is exclusively on PD. Okay, probably by that time we may get some maturity over what you're asking to answer. Okay.
Yeah, Prithvi, one more question from Balaji. Hi, sir, which is a complex script that we use in like Python or TCL other than that?
See, Perl, Tcl, Python, these are the scriptings that we use mostly in our industry. And if you ask me what to learn, I would say it is Perl. Or if you feel it is quite difficult to you, then Python script is enough. Okay, being a fresher, it is good for you to know Python. Okay.
There is a question from Sampath Prithvi. Sir,
Mhm.
what are the requirements for your getting job as a front-end guy?
That's what I have told. You should be good at digital electronics. Then you should be having knowledge on digital Verilog, SV, UVM. Then you should be having some debugging skills and some knowledge on protocols. Yeah.
Fees and course syllabus, that everything. If you are interested, kindly register link. I will let you know about all the details regarding the amount and regarding syllabus. We also have internships in VLSI also. So kindly fill the uh, link and you can approach to you. Yeah. Any more doubts?
Shivani, your voice is break, Shivani.
Yeah. Is
Okay.
it okay, Shaman?
Okay, Saraswati, please explain how to get
Can you check
job in
your
course side.
voice?
It's okay, guys. I am taking up your questions. Okay. Explain how to get job in course side. See, this is what you can do. Whatever the things I told, you can follow the steps and be industry ready. Okay. Without knowing UVM and system, only with VLSI knowledge can we get jobs. It depends here, but it is edge. There is a crowd, and among the crowd many people know digital electronics, and if you know Verilog, it is an advantage in comparison. Even many among them knows Verilog also. If you know system Verilog and UVM, the chances are more for you, right? So why you want to constrain yourself by knowing only single thing? Why not the entire thing? Okay, Sandeep Vangala. Sir, currently I'm working as an electrical maintenance engineer, having couple of years of experience, and I'm able to get this. And how industry will consider me like as a fresher? Yeah, yeah, you will be considered as a fresher only. Question is too long. You will be considered as fresher only, but you can show like your relevant experience is less because you do not have any relevant experience with respect to VLSI core, right? Okay, I need complete notes about VLSI. I have subject in this semester. Yeah, Madella, Manasa, which year are you into? See, if it is final year, I don't think like you will be requiring these things like Verilog, SystemVerilog, UVM. The subject you will be having is with respect to something known as like, fabrication of your mass, like what is a mass transistor, what is a BJT, and what are the fabrication steps like PWEL, NMEL, what is etching, what is photolithography, what is twin tub process. All these things you will be having probably in your course curriculum as part of your semester thing. And okay, so that falls under PDR. Okay, and I need complete notes.
There is
Yeah.
a question from Mohammad Arif. Sir, do
Mhm.
you know about quantum dot cellular automate?
I don't know, yeah. What is this quantum dot cellular automate? I don't know.
Yeah, this is a question from the YouTube. They have been kept in the chat box.
Sir, Mansa is third year, second semester, sir.
Third year, second. Okay, fine. No problem. Okay.
Yes, sir.
Yeah.
So,
Someone asking about LFSR. Who is this? It is pretty advanced LFSR. Yeah. At NIT Delhi, one of my friend worked on LFSR and he even published one paper. Let me see. So we are doing VLSI project as my final year project based on 2022 paper. Probably. Can you name the author? Can you name the author of the paper? High speed counter with novel LFSR state intention. Okay, see, if you want help, you please approach to the institute here. They will redirect you to me. Probably I could help you because I have two of my friends who published paper on this LFSR, whatever you are asking. Maybe I'll direct you there. Okay. Yashitha. Okay, and
sir, it is better than take online or offline courses, sir.
it is up to you. Yeah. It is your personal flexibility. But what I prefer is it is up to you. Basically, the course content, everything will be same whether it's online or offline. It's you who have to decide. Yeah. Okay.
Sir, I am looking into network engineering. Could be you give few tips on how to start?
Sorry, yaar. Please ask. Please let us stick to the relevant content here. And if at all you are interested in network engineering or something like that, my brother is, he already pursued masters. Okay, so I could direct you to him if at all you are really interested into network engineering, cyber security, these things. He's doing his masters, MS. Probably I could direct you to him. You can take some advice.
Prithvi, there is one more question from Chandan. What are the requirements for PD guy apart from analogy electronics?
I'm
Analog
not.
electronics,
See,
sorry.
yeah, one thing is you should be having good knowledge over the scripting, and even there you should need you require the there is one book I forgot the book name. Yeah, probably you should be quite thorough with Razavi. Yeah, Analog Electronics by Razavi. There is some book. If at all you have gone through that book completely, then you're that is like one stop destination for your PD. Okay.
There is one more question from Vinay. Cadence software required.
The Cadence is name of the company, guys. Cadence has something known as Zelium, and that could not be available to you offline anywhere. In fact, what I see over online is Custasim is available. Okay, you can use that.
There is one more question from Manoj Kumar. IFSR means.
Huh? LFSR, that
IFSR,
linear
yes.
feedback shift register. Yeah, that is LFSR. It means linear feedback shift register. Okay. What are the courses like self-paced need to learn before taking training? Not required here because we will be teaching you everything from scratch. I will be teaching you everything from scratch, right from digital electronics. Okay. Like what is a number, binary, octal, decimal. We will be starting right from number systems. If you get
Sir, do
job,
you?
yeah.
Yes. Sir, do you know how about quantum dot cellular automata?
We have already answered this, right? No, I don't know here. I'm sorry.
Oh, okay, sir. Thank you. So, if you want to get job easily by doing MTech or BTech enough?
Yeah, BTech is enough.
VLSI or embedded system, which subjects are useful due to better projects, sir?
Who is this? Madela Manasa. Actually, we
Yeah,
had
sir.
some discussion on this in our last before day session. Like, what is VLSI? What is embedded systems? Which one you should choose? Okay, if at all you are interested in very core of engineering and how a processor is made, what are the things that were involved into the processor, then VLSI is feature for you. If not, you want to use the processor that is already made and you want to embed that onto some PCB and you want to connect it to real life world, then embedded systems is the thing for you. Okay, compared with embedded systems and VLSI has more future, more money, more difficulty.
There is one more question from Sheikh Mohammed Arif. Prithvi, sir, now the trend goes changing from CMOS to quantum dot cellular automate.
I don't know, yeah. I don't know. I'm not sure. See, basically, quantum dot cellular automata. See, now the trend is moving towards nanotechnology. Okay. So, the trend is towards nanotechnology. Scientists are already working on how to use our CNT, that like carbon nanotubes or whatsoever, to build circuits, because we are already at 3 nanometer or 1 nanometer design. So we cannot. There are a lot of limitations that comes into the picture if we keep on scaling down. So that is the reason they are optimizing towards. They are doing something. They are going towards nanotechnology, and they are trying to develop things using that. Okay, probably quantum dot is something with respect to nanotechnology. Yeah.
Which course
Okay,
trend in the
and
course side jobs, sir?
just a minute. Sir, in online class, how can I acquire practical knowledge? See here, we will be providing you the tool. So whether it is offline or online, you will be working on that. Okay, we will be monitoring you. So I don't see any great difference between online and offline, but it is up to you and what you want to choose. Okay.
There is one more question from Rudra Prasad. Is it okay to focus on academics now and then we can go to for the advanced course?
Which year are you into here? See, if at all you are into 4th year, it is required for you right away. Okay. If not, you can be relaxed and come back later.
Yeah, there is one more question from Manoj Kumar. Could you suggest how to start the startups in this VLSI domain?
domain. I cannot tell you that here.
Yeah,
See,
yeah.
Second year, sir.
second year. Okay, okay. So
Yes,
it is not. You are not in a hurry, yeah. Okay. You can play test cricket.
Yeah, sir.
Which is the one job role in VLSI mainly focused on physical fabrication. In physical fabrication, there are many things here, but you will find most of the jobs in layout. If it is physical design, most of the jobs are with respect to layout.
How to approach startup companies?
How to approach startup companies.
Yes.
Even I am starting a company, you can approach me. Oh,
And there
see,
is one more
to
question
answer your
from
question properly, go be active in LinkedIn. Yeah, be active in LinkedIn and follow many guys. As many means follow good guys like team leads, managers, or you try to follow HRs. Then obviously you will come to know like which is a startup. Oh, LinkedIn is the only place of contact where you can do all these things. Okay.
There is one more
Sir,
question from Nikita. In the waveform, how can you decide to change the nano,
What? In the
like
waveform?
in the waveform, how can you decide to change the nano?
Change the nano what?
Yes, that's the question the Nikita has kept in the chat box.
Nikita, let me try to find that question because there are many here. I'm sorry, I'm unable to find that question. Can you please read the question out for me if you don't mind?
Yeah, in the waveform, how
Mhm.
can you decide to change the nano?
I don't know, yeah. I did not get your question. I'm sorry. Yes, I'm not able to hear you here. Yeah.
Sir, their question is how to minimize the system.
Oh, see, with respect to design, you won't see any such changes, whether it is 3 nanometer, 10 nanometer, or whether it is nano. I have told you that, right? See, the front end, the HDL is technology independent. We are least bothered whether it is 50 nanometer, 3 nanometer, 1 nanometer, nano or something, whatever it is. Design is design. It is technologically independent. You cannot see those changes. See, the moment you go to nanoscale, does AND gate becomes OR gate? No. AND gate is still AND gate only. Whether you go to nanoscale or whether it is nanometer scale or whatsoever. Okay, Vanaja is asking, like, in HAW you are providing the whole VLSI course, right? I need only design verification course. Yeah, in VLSI these two things are two different things. One is the front end, other one is back end. Which one you want, you have to choose. And even there will be two courses. One is for front end, other one is for back end. These two things cannot be mixed together.
Yeah, one more question, sir. To the person who's feel tricky in coding like C language, it is difficult to become a DV engineer.
If at all you are not good in coding, then obviously it will be like difficult for you. But no need to worry, because here we are here to train you more onto this, okay? Coding part.
Sir, everyone saying the college subjects is not enough to get a job. Particular subjects needed to college are not 1 minute, sir. Are not providing the practical subjects. They only provide subjects, sir.
Yeah, that's what that is why that is the reason you see all these educational institutions coming up, like all these institutions coming up, and they are grabbing this opportunity, okay?
Your link in any place. Sir, it might be nanoseconds.
No, yeah. No. It doesn't mean that. See, the timing can be anything. It can be microsecond, millisecond, nanosecond, or it can be anything. It depends upon something known as tick time scale. Okay, it depends upon something known as tick time scale. Due to time boundness, I cannot discuss all those things. But no, with respect to that, nothing will change here. You please don't think that the moment quantum dot came into picture, everything falls in nanoseconds. No, it's not like that. In fact, you will get the real-time data in femtoseconds, okay? Not in nano, in femtoseconds, if it is VLSI.
Okay, sir. Sir, it is like physical design. I think mainly focused on fabrication.
Not exactly, but fabrication is also part of physical design, okay?
Okay, so
There is one more question from Saraswati.
Mhm.
Sir, in core side jobs only learn VLSI job enough, or embedded systems is also an important core job?
Yeah. Obviously, embedded systems is also a core job, as like VLSI. But that's what I am telling you. VLSI is more core into electronics. You are digging further deep into electronics. That is where you will be having VLSI. And if you see it at a top level, then that is where embedded systems, you will be seeing embedded systems. And difficulty of embedded systems is slightly less compared with VLSI. As difficulty is more, you are paid more in VLSI, okay? And as we proceed further, jobs for embedded systems might be not exactly, but they might be coming down, because the classic example I could give you is, for example, previously there is some AMD, what they have done. They have initially they used to manufacture CPU. After that, they used to give that CPU to an embedded guy. That embedded guy used to embed this CPU and a memory controller onto a PCB. That is how motherboard was made. But now what AMD is doing, they have invented something known as North Bridge. In that North Bridge, this memory controller and the CPU, both of them, they are preparing on a single chip. Okay, it means that some part of embedded guy has taken away, and that is already taken care while manufacturing the chip itself. So there is a cut down in his role. So that is going to happen in near future. But it doesn't mean that everything will be drastically coming down. If there is a VLSI engineer, there should be an embedded engineer, because VLSI engineer is the one who produces it. Embedded guy is the one who uses it. Okay.
Yeah, there is one more question from Deepika. Sir, in backend is any coding part?
Yeah, slightly. Not as much as front end. Very light. Oh, you can do that. It's not a great deal in coding if it is backend. Even that scripting is also quite easier. If you sit for one week, you can do the scripting if you are intelligent enough.
Sir, please refer some core side jobs from Indra Kaveri. Right.
Please refer some core side jobs. See,
Yeah.
that's what, yeah, that's what I have told you, right? Okay. With respect to ECE, you might be asking, huh? See, the first core job, if it is ECE background, you should be thinking about is VLSI. Else, it is embedded system. These are the two, heart and soul of electronics.
One more question from Hemant. Sir, in this course, what we learning front end or back end?
See, on whatsoever we have discussed, my major focus of area of discussion is with respect to front end. Okay.
And one more question from Manoj Kumar. Sir, how to download the SEdit and MicroWind softwares
Which one? SEdit?
and MicroWind software?
I don't know about these things here. I'm sorry. Someone is asking about my LinkedIn profile here. Please, you search my name in Google like Bijula Prithviraj. You will see all my research publication papers, and you will also be able to find my LinkedIn profile. And I work for VLSI Semiconductors. Okay.
Yeah, Prithvi, one more question from Balraju.
Mhm.
Sir, how to get job in core sector without coding skills?
That is not possible, yeah. Whatever the thing you do, whether it is front end, back end, or whatsoever, coding is mandatory. Okay. Without that, you can't do anything.
Yeah,
Yeah.
guys, any more questions?
Yeah, my LinkedIn ID. Please, yeah, search my name online. You just enter Bijula Prithviraj. Okay, you can even see my publications, all my IEEE papers from ResearchGate or IEEE or whatsoever.
Guys, you have questions for that?
In coming days, AI can write a code from
Yeah,
Hemant.
obviously it can write a code, but it won't snatch your job if at all you are into VLSI.
And one more question from Chandralekha. As a DV engineer, we will be use scripting language like PRL and TC.
Parlant ticket. See, basically, you will be using scripting languages in order to do some kind of automation. Yeah. For example, uh, see, there is something known as regression testing. Regression testing is nothing but in order to verify one feature, you will be writing hundreds of test cases. Or in order to verify your design is working properly or not, you are required to write hundreds or thousands of test cases, and it is manually difficult for you to run those many test cases at a time. So you will use some scripting, and you will automate it in such a way that all the test cases will be running into regression parallelly, or you will be having some different test cases like sanity test case. Okay. So which basically determines the health of a system. So by using the scripting, you will selectively decide how many test cases should be running, how many test cases should not be running, how many test cases should fail. So all these things you will be taking care with respect to these kind of scripting languages as part of DV engineer. I don't know whether you understood my question or not, but what you have asked is kind of high level thing, so I have to answer it in a high level way.
Yeah, and one more question from Prasad. Sir, in this course, are you teaching from scratch?
Yes, obviously, we will be starting right from digital electronics.
Yeah, and one more question. Like the IT sector,
No,
can AI replace VLSI engineers?
no. VLSI industry is immune to automation. See, the more the AI grows, more the demand for AI chips grows, more the demand for AI ML chips grows, more the demand for VLSI guys grows. So you should feel happy, in fact, if AI is growing, because if AI is growing, it needs some chips to be on which it has to run. It means that there is scope for you to get into industry.
And one more question from Namita. Which coding language are required if we are going with VLSI DFT?
Which, see, whether even though if it is DFT, you have to go through. You should have knowledge of all the things whatever we have discussed so far. Digital, Verilog, SV, UVM, all these things they are required here.
And one more question from Rosie Reddy. Java and Python, which course is important nowadays, sir?
I don't know, yeah. Probably I would say Python.
And one more question from Nitin. What is the difference between COP and POS in digital electronics?
COP, POS?
Yes.
Probably you're talking it with respect to minimization of K-maps, right? Yeah, I cannot explain that here because it would take time. Huh? That they are basically the minimization steps that you should follow while solving your K-map. Probably you are from first year or second year of BTech. Maybe you are asking that doubt.
India is still depending on other countries for manufacturing in chips.
Yeah, obviously. That is the reason we are going to have some fabs in Gujarat and in Northeast, probably in Arunachal Pradesh or in some place. So there is huge demand for VLSI engineers in coming days, guys. As I have already discussed to you, like there is more than 3 lakh engineers deficiency is going to arise in near future. So you all will be placed there.
And one more question from Omkar. How to get job in VLSI as a fresher? I think it is hard to enter in VLSI sector.
No, yeah, we have already answered this question. It is not hard. You can enter. You just need to learn or just follow the roadmap that we have discussed so far. Okay, yeah. Any other doubts?
Yeah, one question from Harshad. Where do we learn STF from?
STA. If you want to learn STA, I would say YouTube. Yeah, in YouTube there are a lot of videos who will teach you STA, static timing analysis. Please search some concepts of STA, then you can find a number of videos.
So what is the intentional package for
Initial
freshers?
package, it depends, yeah. If at all you are directly placed into Intel, you will be getting something around 22 to 25 lakhs. If at all you are placed into Qualcomm, you will get 32 LPA. Okay, if you go get placed into NVIDIA, you will even get paid more. Okay, it depends upon your skill, and it depends upon into which industry, which company you are entering. If you directly entered into a service based company, they might pay you 6 lakhs or 8 lakhs, that's it, not more than that. Okay. Okay, I hope we are done with this.
Yes, Prithvi. Yeah, guys, kindly reminding that we are providing job-oriented training on VLSI. First, we're in the HIEE. So kindly register for if you are interested, kindly register. And if you have any doubts, our team will approach you regarding the amount and everything. So kindly register. And thank you for your valuable time. And thank you, Prithvi,
Yeah,
for your
thanks. Yeah,
wonderful
thanks.
presentation and speech.
Okay, thanks Shivani, and thanks everyone. Hope to see you in online or offline class, whether you join me or not, but make sure that you're not wasting any time and utilizing your time properly. And I still feel, I strongly believe that whosoever attended in this session, more than 500 people, among them at least, I am pretty confident that at least 5 of you will be having your own startups in next 10 years, because that is the potential our industry is going to have in our near future. Okay, thank you all, and all the very best for your future. Thank you so much.
Thank you, Prithvi. Thank you.
Yeah, good night.
Thank you, sir.